Hey, I'm Sid.
My name is Wilmer.
I'm Henry.
And this is our physics video project.
Today we'll be talking about the topics of circular motion, torque, and gravitational force. Bear with us, guys. This may be a little boring in the beginning, but the rest, nearing the end, it'll be really funny. Trust me.
The last 30 seconds are lit.
And since we're not all boring, we decided to add a little physics joke. Mr. Hong might get this reference. Hopefully he does. Alright. Two atoms are walking down the street.
Wait, I think I just lost an electron.
Are you sure?
I'm positive. Ha!
These guys are great.
Yes.
Rolling on to the video. Let's go.
What people do not realize is that we use torque in everyday life, such as for simple things as opening the door, or something as simple as turning on a water faucet. Because we use torque in everyday life, and we also use force. You use force when you want to move something, but you use torque when you want to rotate something. This is a demonstration of torque. As you can see, as I move my hands, I can always find the center of the balance to see where exactly to balance the weights, or just one in this case, or if I just remove it, you can see that I can find the center of the balance of this tube. As you can see, this is something that most common people do when they're bored or something. But this is actually engineering torque because it keeps balance. You notice that it's easier to move the pencil side to side if you do it around the pivot point. But if you do it from one of the ends, you notice that it gets harder because the balance is uneven. If you do it from another end, you can notice it gets harder instead of doing it from the center. This is a demonstration of torque. Wilmer is gonna stand on the opposite side of the wood while he holds it down. This demonstrates torque because it keeps balance for the wood, and it's the reason why he doesn't fall and die. So
Physics, guys.
physics. Anyone that has ever thrown a frisbee would know the most important part of the frisbee is its spin. The spin creates an angular momentum that causes it to stay afloat and increase speed. This mysterious force is also known as centripetal force. So we filled this bucket halfway, and the trick is, if you swing it fast enough, the water shouldn't fall out. If I mess up, then it does. The reason is because if you swing it fast enough, you create enough centripetal force for the water to move tangent with the bucket. So, alright, I'm gonna go for it.
This is a demonstration of circular motion. As you can see, the Beyblade is in a constant speed in a circle. As an object moves in a circle, it is constantly changing its direction. At all instances, the object is moving tangent to the circle. Since the direction of the velocity vector is the same as the direction of the object's motion, the velocity vector is directed tangent to the circle as well.
Go. As such, all objects free fall at the same rate regardless of their mass, because the 9.8 kilogram gravitational field at Earth's surface causes a 9.8 meters per second acceleration of any object placed there. We often call this the acceleration of gravity. All objects fall at the same rate regardless of their mass or size.
Okay. So today I'm going to teach y'all about centrifugal force. So when you're on a roller coaster and it suddenly just sharp turn to the right and you just jerk left, that force is the centrifugal force. So centrifugal force is the force pushing you towards the center of the circle, causing you to move in a circle. So let's break this down a bit. So let's say we have Sydney, okay? weird child in school. She decides to tie a ball at the end of some string. And she decides to like whip it as fast as she can around in a circle. Okay? This is centrifugal force. So the object is moving in a circle. We call the ball an object. So the object is moving in a circle. So the force between the object and the center of the circle is the centrifugal force. So in this case, it would be the string right here. Fun fact. So this is a fact that Newton actually came up with. That's like, it'll blow your minds away. Okay? So an object moving at a constant speed is accelerating. What? What did you say? Yes. An object moving at a constant speed is accelerating. Why? Okay. So first let's start off with the actual equation of acceleration. So acceleration stands for the change in velocity over the change in time. Well, let's look more closely at velocity. So velocity is broken into two parts, which is speed and direction. Now, velocity is always tangent, so its direction is always changing like so, and so on. We mostly always focus on speed. That's why this is so bizarre to us. But in fact, if you actually think about it, since it's moving in a circle and velocity is tangent, the direction is always changing. Therefore, the velocity is changing. And the acceleration as well is also changing. But let's say you want to find the centrifugal acceleration. So just the centrifugal acceleration, that would be velocity squared over the radius. That's centrifugal acceleration. Okay, but right now we don't need that. We need the centrifugal force. And force is acceleration times mass. So we just need to add mass to this basic equation and we'll have the centrifugal force equation. Centrifugal force would then equal mass times velocity squared over the radius. Cool? Cool. Okay, so let's solve an equation. So let's say you have a 2 kilogram ball attached to a 0.5 meter string and is spinning at 3 meters per second. Okay, so we're just going to plug this in. So for the mass, 2 kilograms times the velocity squared, which is 3 meters per second. So we're just going to multiply that. 3 meters per second squared. And the squared is very important because if you mess up one part of this equation, everything's going to be wrong. So squared is important. Don't forget about it. Most people forget. That's why. And the radius, which is 0.5 meters. 0.5 meters. Okay. So 3 squared, 9 meters per second, multiplied by 2 kilograms, is equal to 18 kilogram meters per second squared. All over 0.5 meters. So many labels. How do you do this? Okay, so actually, this meter right here could cancel out since it's square, and you just cancel out the bottom one. The speed here could actually be moved down. So that's simple. So then you're left with 18 kilogram meters over 0.5 seconds. And then you solve that, and that is equal to 36 kilogram meters per second. In reality, kilogram meters per second is actually shortened to 36 newtons. Okay, so I'm going to teach you guys how to solve for gravitational force. So the gravitational force equation is Fg, gravitational force, which is equal to gravity times the first mass times the second mass divided by r squared. Okay, so this G stands for 6.67 times 10 to the negative 11. Okay, so let's actually solve an equation with this. So let's say, okay, so first you have to plug in G. So let's say that the first mass is 5.98 times 10 to the 24th times the second mass, which is 7.26 times 10 to the 22nd. All divided by the radius squared, 3.84 times 10 to the 8th squared. And so then after plugging this into the calculator,
This is how you would plug it into the calculator. First you would type in 6.67 e, because that stands for 10, to the negative 11th power. You would equal that. Then you would multiply it by the first mass, which is 5.98 e to the 24th power. You will get that. Then multiply it again by the second mass, 7.26 e to the 22nd power. You get this, and then you would divide it all by open parentheses to 3.84 e to the 8th power close parentheses squared. And this would be your answer.
so I'm going to teach you about torque. So the basic formula for torque is force times the radius, which is equal to the force times the radius. So this is like basically how you find torque. So let's use an equation. So you have two dogs that are sitting on a balance of a teeter-totter, like so. So one dog weighs 45.2 kilograms and is away from the point of balance at 1.3 meters. Okay, so then the second dog is at 2.15 meters from the teeter-totter, and our goal here is to find how much it weighs. So you plug in the force with the mass, and so 45.2 times 1.3 equals F, because we don't know what F is, times 2.15, and we just solve. So 4.5 times 1.3 is Henry.
58.76.
Is equal to F2.15. So now you divide 2.15 from both sides to isolate the variable. And so then 58.76 divided by 2.15 makes F equal
27.33.
27.33. So therefore, the mass of the second dog would be 27.33 kilograms. Thank you.
What?
What?
Just kidding, guys. We hope you enjoyed this, and hopefully it was funny and learnative.
Yes.
Alright, guys, we're doing this outro, and we're saying goodbye. Hope you
Bye.
have a good one.
Yes. This took a lot of hard work and dedication. Henry cried when we wanted to die.
I was a test dummy. It's
He almost died.
it's great.
Yeah.
I fell off a table.
Pulled an
You see
all-nighter
this?
and also cried. Yes. But thank you, Mr. Hong, for teaching us physics. Completed our lives.
Thanks, Hong.
The effects of all this.
Couldn't do it without you.
I know.
Thanks, Hong.
Such simple thing. I don't understand iPhone, I'm sorry.
I mean, just see this, guys.
I'm sorry! We would know that the most important thing is its spin. Oh my! Throw it, it
Okay.
Alright, so today I'm gonna be teaching you guys about gravitational force.
Ooh.
Bam! Alright, let's do this. Okay. G gravitational force equals 6.67 times 10 to the negative 11 power. This is like blooper.